Hello, this video is to help you with Lab 2 on linear regression using R. The data set I'm going to discuss here is on climate change. I'm looking at a set of countries as my sample, and the variables are the CO2 emissions in tons per person and the GDP, that's the income, also per person per country. So I'm thinking that the more income the country has, the higher the emissions, the CO2 emissions are. But I'm interested to see whether there are some outliers. Is it possible to have a rich country with low CO2 emissions? But I don't know whether I'll get to that in the video. So anyway, get the working directory will show me that's where I want to look. That's where my file is. If need be, you set the working directory to where your file is. And now I'm going to access my data. I'm going to call the data frame climate. And so I need to read that in. It's a CSV file. And the name of the file is GDP and CO2. GDP and CO2 .csv. It worked. 185 observations in 3 variables. Okay, so first, let's have a look at it. Let's plot. Oh, so what am I plotting? I need to know what the variable names are. So I'll use the names function to see what the variables in the, so GDP and CO2 emissions. So CO2 emissions, that's my dependent variable. That's going to come first here. CO2 emissions. I'm going to make a scatter plot. And that depends on GDP. The data that I'm drawing is from is climate, it's the data frame. Here we go. Very bad choice of color. So I'll use a up arrow and let's make that blue. Much nicer. Oh, isn't that lovely? So looking at the scatter plot, it does seem like there is a positive correlation. There's one particularly rich country with really high CO2 emissions. Especially down at the low end of the scale, looks like there's a positive correlation. So the correlation is part of this, but the other part is to draw a regression line. So let's put the equation into a variable. I'll call that regline. So regline is a linear model using CO2 emissions, which we think are dependent on GDP. Data set is climate. And I'll do it. Okay, so we want to see that on our graph. So I can do that with the abline function. The line width is 3. We'll make this red. And there you have the linear regression line, and you can see it has a positive slope. Well, what is the slope? Let's see. Using the summary command, I can see some of the statistics here and the significance level of those statistics. So there we have the intercept is 1.941. That would be the predicted CO2 emissions of a country with 0 GDP. And the slope is 0.146. Now, the income there is in thousands of dollars. So that means for each additional $1,000 in income, CO2 emissions are predicted to rise by 0.146 tons per person. More money, more pollution. And you can see the significance level. They have very high T levels associated with very small p-values because the sample size is large. We have 185 observations. And so, yeah, it's interesting. It's highly significant correlation, even though, where's our R squared? Oh, R squared is 0.2972. So if you look at the correlation coefficient, it's the square root of that. So not a really high correlation, higher than 0.5, but not really high. And yet highly significant t-value. The t-value and the p-values mean that we have a high level of significance of this linear model. So that was briefly how to do regression using R. Bye for now.